we have a question. How will you express the standard form of a line into the normal form? So here the standard form of a line is ax plus by plus c equal to 0. And what is the normal form? The normal form is x cos alpha plus y sin alpha equal to p. So to explain you the normal form again, what is the normal form? So I just draw one tiny diagram. This is my coordinate axis, this is the line, and from the origin a perpendicular of length p is drawn, and this perpendicular is making an angle alpha with the positive direction of x-axis, and this is p, and this form is called the x cos alpha plus y sin alpha is p. Now what we are trying to discuss that how can we express this into this form. So the idea goes very simple. Like suppose if this normal form is this, so here I write x cos alpha plus y sin alpha minus p is 0. So if these two lines represents the same thing, so it means their coefficients should be in same proportion. Means a upon cos alpha, coefficient of x, is b upon sin alpha is c upon minus p, and then we can call them r or anything, but if you're not interested you can leave it like that only. So here I compare the first with the last one. So I get a upon cos alpha is c upon minus p. So cos alpha is minus ap upon c. Similarly, sin alpha will be minus pb upon c. Now I want to get rid of this alpha. So how we can get rid of this angle? So we know that the trigonometrical identity suggests that the sin square alpha plus cos square alpha is 1. So sin square alpha plus cos square alpha is 1, means this square plus this square is 1. That is a square p square upon, this is p, a square p square upon c square plus p square b square upon c square is equal to 1. It means if I take p square over c square common, then I'll get a square plus b square is 1. So what you see that a square plus b square is c square upon p square, or p square equals c square upon a square plus b square, and p is c upon under root a square plus b square. So we have been able to find p. Now we need to find alpha, sin alpha and cos alpha. So how will you find the cos alpha? So cos alpha, you have seen that cos alpha is minus ap upon c, minus ap upon c, that is minus a upon c, and the p is c upon under root a square plus b square, that is just minus a upon under root a square plus b square. And similarly, this is your cos alpha, and sin alpha is this one, which is, sin alpha is minus pc, so this will become minus b upon c into c upon under root a square plus b square, and this is minus b upon under root a square plus b square. So now I have to clear the screen because now you understood this is how you can find the sine alpha, cos alpha and the p. So this equation anytime you can write in terms of this by using these. Now here we are interested in finding out the angle between the two straight lines. Suppose I have a line which goes like this. This is line L, and there is another line which goes like this. This is line M. And now we are interested in finding out the angle between them, theta. I call it as alpha theta. We will find. So now suppose that if this is line L1, so this is making angle theta 1 with the positive direction of x-axis. This is theta 1. So the L1 is making this is x-axis, this is O, this is y-axis. So the line L is making angle theta 1 with the positive direction of x-axis. What does it mean? It means that the slope of the line L will be tan of that angle, tan theta 1. Similarly, if the line M is making angle theta 2 with the positive direction of x-axis, then what is slope of line M? That I can write as M of line M is tan theta 2. Now we have to find the relationship between theta, theta 2 and theta 1. Now you see that the theta 1 is the exterior angle for these two, theta and theta 2, and we know in geometry you have studied that the exterior angle theta 1 is equal to sum of the co-interior angles or the interior angles on the opposite side. That's called as theta 1 is equal to theta plus theta 2. Therefore theta 1 minus theta 2 is theta. This is what we have to find. But if you see theta, then we have to find the angle. Then how can we find? So we use tan theta. Now use the idea. We have to find tan theta, like tan of the angle theta. Now what is tan of angle theta? The tan theta is theta 1 minus theta 2. Now you know that the theta 1, tan A minus B is tan A minus tan B. This is tan A minus tan B upon 1 plus tan A tan B. Theta 2 we write in the mod, or even if you can leave like this. Now theta 1, you all know that the theta 1 is tan theta 1 and this tan theta 1 is the M. So instead of using ML, for convenience if I write M1, so the slope of this line is M1 and slope of this line is M2. Slope of this line will M2. So here what you will get, tan theta is equal to, here, is it properly seen? So tan theta equal to M1 minus M2 upon 1 plus M1 M2. Is it clear? Is it seen properly? So
Yes.
everyone understood this one? Can I write here? Or
Yep.
should I write there?
Yes, you can write there.
Okay, so just give me 1 second, I have to clean this screen. So now you see the angle between the two lines is given by the formula tan theta is M1 minus M2 over 1 plus M1 M2. Now here we'll discuss some cases. Case 1, like if the lines are parallel. So like if the L is parallel to M, in that condition the theta will become 0. Theta will 0 means line L is parallel to M. And what is tan 0? Tan 0 is 0. So tan 0 is 0. So this will become 0. It means the denominator should be non-zero and the numerator should be 0. So what we get? M1 minus M2 equal to 0, and then we get the case M1 equal to M2. So what is our idea? If two lines are parallel, then their slopes are equal. Now case 2, when the angle between them tan theta is 90. So if theta is 90 degrees, lines are perpendicular to each other. In this condition, tan 90 becomes undefined. And what does it mean undefined? Undefined means the denominator is non-zero, but the numerator is like this one is 0 and this is non-zero, because we have to study the case of 1 by 0 is infinity. So 1 plus m1 m2 now will become 0. So 1 plus m1 m2 is 0, therefore m1 m2 is minus 1. So this is the case that if two lines are perpendicular, the product of their slopes is minus 1. Now in the next episode, not the next video, in the very same video that I again have to clear my screen, and then we'll discuss how you can find the perpendicular distance between the two lines. Okay, now we have to find the perpendicular distance of a point P x1 y1 from a line ax plus by plus c equal to 0. So we get, like suppose this is the point P with the coordinate x1 y1, and this is the line with the equation ax plus by plus c equal to 0. Then what you have, suppose this is PM, then you simply have to find PM this way. Satisfy this point into this line, so this become ax1 plus by1 plus c upon under root coefficient of x square, that is a square plus b square. This is the formula for finding the perpendicular distance of a point from a line. So suppose sometimes we get the situation like how to find the perpendicular distance between the two lines, and if they are parallel, so just anyhow you have to find one point on this line and then you drop a perpendicular. Using this method you can find the perpendicular distance between these two lines. Now in this video only till now, and next ideas and some leftovers of this straight line we'll discuss in the next video. Thank you very much.